Alright, example problem 3 from lesson 10. You are standing on the surface of the earth and throw a rock straight up into the air at an initial velocity of 15 meters per second. We want to know how high will the rock rise before it starts to come back down. We can certainly use the kinematic equations we've used before, but for this particular example we are going to look at using the conservation of energy. So we have our person says hi, he throws his rock, it goes up, gets to the highest point, and then starts to come back down. So we are looking for what is this value, what is the max height that it gets to. We're going to go ahead and set where that initial position is, that initial height from the ground, equal to 0. These two things matter because we are going to be looking at the fact that the only force acting on the rock once thrown is gravity. All right, gravity is a conservative force. Which means we see a conservation of mechanical energy. Our initial energy is going to equal our final energy. All right. So if we are looking at our initial energy is made up of our initial kinetic plus our initial potential. So our initial kinetic is that 1/2 mvi squared, and our initial potential is mg HI. Because our initial height is 0, this last term does go away. Now we're going to build our equation for our final mechanical energy. It's our final kinetic energy plus our final potential energy. We can see our final kinetic is 1/2 mvf squared plus mg hf. We are looking for the height at this particular point, so we can consider the velocity at this particular point. When an object is at the highest point in its path, its velocity is 0, so this term goes away. As a result, we get that our initial energy is equal to 1/2 mvi squared, our final energy is equal to mg hf. We can set these then equal to each other. Right. I do have mass on both sides of my equation. They are going to cancel. And when I solve this for my final height, I do get the fact that my final height is equal to vi squared over 2g. I can now plug in everything that I have. And I do get the fact that we go up in the air 11.5 meters.